Identifying a domain from a picture means just looking left and right and seeing where that picture exists. Not all of the functions that you deal with will be a graph that you immediately recognize or can imagine for yourself. So in trying to identify that set of x values that are going to constitute the inputs, we need to keep a couple of things in mind. And they're long-standing ideas that from the beginning of a lot of the operations that we've learned still are things we look out for. We want to avoid dividing by 0, which means we're going to eliminate any x values that would cause that to happen. And we also want to avoid taking square roots of negative numbers. Now, negative numbers aren't an issue once we move far enough into an Algebra 2 course and we can work with imaginary numbers for solutions to equations, but in terms of the domain and range of a function, we work in the real number system, and so imaginary outputs wouldn't be part of the scenario. So we need a function to work with. We'll start simple. Something like 2x plus 5. Now we have those two ideas that we're going to check for. We worry about whether or not we're going to divide by 0. Well, there's no variables in denominators in that equation, so we don't have to worry about dividing by 0. And there aren't any radicals as a part of that equation, so we don't have to worry about taking the square root of any negative numbers. That being said, the broadest spectrum we can have in terms of domain is all real numbers. So here our domain is going to be from negative infinity to infinity. It's all real numbers. Things change as the function changes. If we have the function g at x equal to the square root of 3x minus 1, now still keeping those two things in mind because those won't go away, dividing by 0. We don't have any variables in denominators. Dividing by 0 won't be an issue. Square root of a negative number. Well, now we can see here that there is a radical as part of this equation. 3x minus 1 being the radicand. If we were to allow all real numbers for values of x, at some point 3x minus 1 could equal a negative value. So we need to restrict it so that we don't get negative values, which means we need to acknowledge the fact that we want 3x minus 1 to only yield values that are greater than or equal to 0. So we'll write that. If 3x minus 1 is going to be greater than or equal to 0, that means that 3x is greater than or equal to 1, and x needs to be greater than or equal to 1/3. There's the domain we're looking for. That is the restriction we need to put on this function, and so our domain would be from 1/3 to infinity. Now we have a denominator. Do we worry about whether or not we're going to divide by 0? Absolutely. 3x plus 4 could potentially be 0. Now, keeping that in mind, we don't want it to equal 0, so we will write ourselves an equation that says 3x plus 4 does not equal 0 to figure out what value we don't want x to equal. Working that through, x is not equal to negative 4/3. So that will be the value that we'll eliminate from that broader domain idea. Square roots of negative numbers, not an issue. There are no radicals here. So the only restriction is don't let x be equal to negative 4/3, and so we write our domain to not allow x to equal negative 4/3. Final example. Here we have both variables in a denominator as well as a radical present. So that doesn't change anything about our thinking. Both of these things need our focus. So starting with the idea of the radical. We don't want to take square roots of negative numbers, so x plus 1 needs to be greater than or equal to 0. If we solve that through, that means that x is greater than or equal to negative 1. Now, the second idea is that the square root of x plus 1 can't equal 0 because it's the denominator of the fraction. Well, if I square both sides, I'm at x plus 1 is not equal to 0. Subtract 1, x is not equal to negative 1. Taking those two things into consideration, I arrive at x is greater than negative 1. Now, having acknowledged that, I can write my domain. My domain is -1 to infinity, exclusive of that -1 value.